Okay, so this video is just a continuation of Unit 2, Part 1, Lesson 1. And I just wanted to point out that in the packet that you're able to download for this unit, there are some descriptions, how to compare our interval notation with set or inequality notation. So this first block of text is just reminding us what a closed interval means and when we would use it. So again, we're using square brackets, A, B, representing our endpoints, and that would be the same as the inequality A less than or equal to X less than or equal to B. So essentially the squared brackets, these square symbols, go with inequalities that contain an equal sign. If we were to use an open interval, this parenthesis grouping symbol, that's what's associated with the inequalities without an equal sign. And then the half open in either direction would consist of one parentheses and one square bracket, again in either position, which also relate to inequalities with and without our equal sign. When we want to show that a number is getting infinitely large, or a range of numbers or an interval of numbers is infinitely large, we use infinity as an endpoint to the interval, and that's also related to this notion here, saying that x or y is greater than a single endpoint. So again, you can use this text or this chart to help identify when or what your interval or what your inequality notation should look like. Again, this inequality notation is sometimes called set notation with a couple other parameters involved. And if we were comparing the interval and set notation to what the graph might look like, you might see this here. Now, one thing I might point out on our number line graphs is that we don't often label positions with parentheses or square brackets. Instead, what you'll often see are open circles or filled in circles. So if you ever saw a graph on a number line that was connected with open dots or closed dots, that's what's really going on here and how they relate to our current point of discussion. Parentheses are represented by open circles, and brackets are represented by filled in circles or dots. So should you see any of this in Math Excel or on any Khan Academy assignments, hopefully you recognize the similarities and the differences now. To finish out this video, I'd like to run through a few practice problems down at the bottom of the page. And I'm not going to work through all of these in this video. I would ask that you give them each a try, but I'm going to work through, say, the first three, 49 to 51, and I'll let you try the others on your own. I'll display the solutions at the end of this video. But in problem number 49, if we have the inequality 3x minus 7 greater than 2, and I'd like to report our answer in both set notation and interval notation, I would solve this something like this. I would add 7 to both sides. I'd have 3x greater than 9. Now I can divide both sides by 3, and I know that x must be greater than 3. And that would be a good solution in set or inequality notation. As far as interval notation goes, we would have to say something like this. X is among the element, or x is an element of the numbers from 3 to infinity, and we're going to group those with parentheses. And again, this is our way of saying that x exists somewhere between the numbers 3 and infinity. It can't exist at the number 3 because we didn't have an equal sign, but anything slightly bigger than 3 up to infinity. And of course, infinity is unreachable, so that's a good way to represent this solution. With number 50, 2x plus 5 greater than 1, so 2x must be greater than negative 4, and x is greater than negative 2. Now, I deliberately didn't show any of my steps in between. I didn't indicate that I subtracted 5 from both sides and then divided by 2. because at this point in your mathematical career, I don't think you need to show each of those steps if you don't feel that it's necessary. If you'd like to show it, that's fine, but it's not absolutely necessary. So here again, our answer in inequality or set notation looks like this. As far as interval notation, we would say that x must be among the numbers from -2 to infinity, and neither one of those have bounded results, or boundaries are not included, so I like the open print. With number 51 here, we'll go ahead and subtract 1 from both sides, and we now have -2x less than or equal to 2, and divide both sides by -2, and that leaves me with a -1. Now what's really important here is that we change the direction of our sign. And we always have to flip the sign when we multiply or divide to isolate the variable. And in this case, we had to divide both sides by -2 in order to get this variable by itself. We didn't do that over here, though. We did divide a negative number, but we didn't divide by a negative number. We divided by a +2 in order to isolate this variable. And therefore, we didn't have to change the direction of our sign. In this case, we did. Now we can look at this a different way. If I had 1 minus 2x less than 3, what if I subtracted 3 from both sides of the equation to move the 3 to the left, and then added 2x to both sides of the equation? I would end up with something that looks like this. And now when I divide by 2, this is a +2 that we're dividing by, we would end up with an answer that looks like this, -1 less than or equal to x. And at first glance, you may not recognize whether these two represent the same thing, but let's consider the interval notation. Here we're talking about x values that must be bigger than or equal to -1. So we're talking about x values that start at -1 and get larger. And well, we're talking about the same thing here. We're picking all x values that must be greater than or equal to -1. All x values that start at -1 and move larger. On a number line, it may look something like this, where we have -1 and say 0 and +1. We want all solutions that exist at -1 and move larger towards infinity. So again, either of these answers would be correct. This is our interval notation. This would be our set or inequality notation, and those are just fine. Go ahead and try 52 through 57 on your own. Pause the video now and resume playback in a moment to check your work.